Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Iftikhar Iman bin Miswari. My student ID is 2023 654 996. Today I would like to share about introduction about this topic. Logical equivalence is fundamental concept in logic and reasoning that plays a critical role in mathematics, computer science, and philosophy. It refers to a relationship between two statements or propositions that always share the same true value under every possible condition. In other words, two statements are logically equivalent if they are true or false simultaneously, no matter the circumstance. Logical equivalence help us simplify complex argument, identify redundancy, and ensure clarity in logically reasoning. It serves as the foundation for proving the validity of statement and constructing logical proof. For instance, the expression not both and is logically equivalent to either is for or is for, as confirmed by De Morgan's law. Understanding logical equivalence is essential for recognizing that different expressions can represent the same logical idea. For example, consider the two statements. The first statement is, it is not true that both P and Q are true. The second statement, either P is false or Q is false. Though these statements are worded differently, they are logically equivalent as proven by De Morgan's law.
Alright, so here we have four statements for the logically equivalent. So first one we have conditional, inverse, converse, and contrapositive. Alright, so for the conditional we have P implies to Q, and for the inverse we have negation of P implies to negation of Q. And for the converse, we have Q implies to P, and for the contrapositive, we have negation of Q implies to negation of P.
For the next slide, I will talk about an explanation about question 1. For the statement is, if Haikal save enough money, then he will buy a new car or go on a vacation. For the statement P, Haikal save enough money. For the Q, Haikal will buy a new car. For the R statement, Haikal will go on vacation. For the statement P implies to Q or R. For the converse statement, Q or R implies to P. If Haikal buy a new car or go on a vacation, then Haikal save enough money. For the inverse statement, nego P implies to nego Q or R. If Haikal do not save enough money, then he will not buy a new car or go on a vacation. For the contrapositive statement, negotiation, open the bracket, Q or R, close bracket, implies nego P. If Haikal do not buy a new car or go on a vacation, then Haikal do not save enough money.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Tuan Ara Haikal. My student ID number is 202-3F5-5898. So now I will continue to question 2. So the question 2 sounds, by using truth table, show that nego M and nego N and nego N logical equivalent to M and nego N. So first we will go to M. M is true, true, false, false. N, true, false, true, false. Nego M, false, false, true, true. Nego N, false, true, false, true. Nego M and nego N, false, all false. Then nego M and nego N, close bracket, nego, all true. Then nego M and nego N, close bracket, nego, and nego N. true true false false. The last one, M and nego N, true true false false. So we can see here on the table that the second last one and the last one is same. So since the truth table are identical, therefore nego M and nego N, close bracket nego and nego N, and M and nego N are logically equivalent.
So before this, we just look at example for how to do logical equivalence for using the truth table. So right now we will use other methods that is by law of logic. So here's for example the law that we have in logical equivalence. We have identity law, we have associative, distributive, De Morgan's, and others law. For question 3, we need to simplify this statement P implies Q, disjunction in bracket Q, disjunction R, conjunction Q, disjunction nego R by using law of logic. So for first step, we use distribution law. We simplify the last bracket. We will get Q, disjunction R, conjunction in negation R, and then for R conjunction nego R, we can use inverse law and we will get tautology. After that, we use identity law. We will get Q only. And from that, we will use implication and we will be nego P, conjunction Q, disjunction Q. After that, we use absorption law.
All right, so here is the question 4. For the question 4, the question is, show that in a bracket, negation P, disjunction with Q, close bracket, conjunction with negation P, close bracket again, and disjunction with open bracket, negation P, conjunction with Q, close bracket, disjunction with negation Q, close bracket again, is logically equivalent with negation in a bracket, P conjunction with Q by using laws of logic. Okay, so for the long statement one, for the first statement there, which is in a bracket negation P, disjunction with Q close bracket and conjunction with negation P. There we can simplify pronounce it as A, so that it is much easier to pronounce. So from the question, it can be A disjunction with B, which is logically equivalent with negation in a bracket P conjunction with Q by using laws of logic. Okay, so for the first one, what we can do first, we will proceed for the A statement earlier. A equation statement, which is in a bracket negation P, disjunction with Q, close bracket, conjunction with negation P. That is the A1. That is what A is. From there, what we can do, we can use absorption law, which is we simplify it and we will get negation P only. So that's for the A1, for the A, and for the B, we can use distributive law, which we will expand it. So here we will expand the negation Q with the statement in the bracket here. So it will become um, negation Q, disjunction with negation P in a bracket, and conjunction in a bracket, negation Q, disjunction with Q, close bracket. And after that, what we can do, we can use inverse law. For the inverse law, we will simplify the negation Q disjunction with Q statement, which we will get T or tautology. And after that, like usual, once we use inverse law, we will proceed with identity law. So for the identity law, we will simplify it, so it will become, for the B, it will become negation Q, disjunction with negation P only. For the tautology, it's disappeared, like just like that. All right, then what we can proceed with as associative law. Actually, we can proceed with associative law. For the associative law, we change the bracket place. So here, supposedly we can use commutative law, but it's okay if we already know what to do. So we change the negation Q, disjunction with negation P, we change place between two of it. So it will become negation P, disjunction with negation Q, and in a bracket firstly. And then after that, we can use associative law, which we will change the bracket place. So it will become in a open brackets, negation P, disjunction with negation P, close bracket, and disjunction with negation Q. After that, what we can do, we can proceed with idempotent law, which will simplify the statement in a bracket here. So it will become negation P only, negation P, disjunction with negation Q. And for the last step we can do, we can use De Morgan's law. For the De Morgan's law, we just put the negation outside of the bracket. So it will become negation in a bracket P conjunction with Q, close bracket. As to why we need to use De Morgan's here is because we want to fulfill what the question wants, which is we want it to be logically equivalent with negation in a bracket P conjunction with Q.
So now I will conclude this presentation. To sum up, logical equivalence refers to a relationship between two statements or propositions in logic where they always have the same true value in every possible situation. If two statements are logically equivalent, it means first, they are true under the same condition. Second, they are false under the same condition. And the last one statement can be replaced by the other without changing the meaning or outcome of an argument. So how to determine logical equivalence? So there are three ways to determine logical equivalence. The first one, we will use truth table. We will create a truth table for both statements and verify if the true values match for all possible scenarios. The second, logical laws. Use logical equivalence like De Morgan law, double negation, or distributive laws to rewrite one statement into another. So the last one, contraposition or conditional proof. For conditional statements, check their contrapositive forms or deduce one statement from the other. So we have one example. The example is the statements and are logically equivalent because the order of conjunction doesn't matter. Commutativity. That's all from us. Thank you.